In January of 2001, I headed off to Capitol Hill with my freshly minted PhD in theoretical and applied mechanics. Theoretical and applied mechanics, Capitol Hill. How do those things fit together? It's not immediately obvious, especially because us scientists and engineers tend to seek out an environment where logic and rationality reign supreme. I was a news junkie in grad school, though, an NPR junkie, actually. And I applied for a congressional science fellowship out of curiosity. So on this day that I went to Capitol Hill, I was going to my first day of work in the senator's office. And on that first day of work, his legislative director, someone who has a very keen interest in science and technology policy, took me down to the basement cafe to have a cup of coffee and to outline my priorities for the year. So he sat down. He's a very energetic person, and he listed off very quickly these 5 or 6 tasks, none of them trivial. I laughed and I said, "Oh yes, and save the world too, right?" And without missing a beat, he said, "Well, if you didn't want to save the world, you wouldn't be here." Now I'm at OSU. And at OSU, we have an awful lot of neat work, really exciting work going on in energy and water. So take here Professor Ganti-Multi's work on converting or on generating power from algae, or the work over there to the right from the late Rich Peterson, a thermally based concept for storing grid energy. You know, especially, engineers, and especially engineering professors, we really value complexity. So we make our grad students build these really complicated experiments, or we make them write really complicated computer codes. And I should know, I was a grad student, and I actually really love the challenge of a complicated experiment as much as anyone. But in the past couple years, or I should say, in evolution here, I've been thinking about how we design things. How do our designs evolve? Okay, let's look at this. Remind you of being 6? Maybe. Your bike may not have been purple and white, and if you didn't live in Oregon, it probably didn't have fenders. But this one does, at least in the back. The front one's off. So how do you teach a child to ride a bike? How does a child get on the bike and learn all of these skills together? Learn the pedaling, the steering, the braking, and the balance all together. How do we do that? Well, you have a couple of options here. Let's look at 2 different choices. Let's look at one choice, increase complexity. Okay, training wheels, a little bit of complexity. Not a lot, but still complexity. Or decrease complexity. Reduce it to the very basics. What do you have here? You have a seat, you have wheels, and you have a handlebar. And that's it. And the child runs along until she gets up enough speed, then picks up her feet, coasts along. And it very effectively isolates learning of steering and balance without all the rest of the stuff, without pedaling and braking. Oh yes, braking. Well, it's a little hard on the shoes, shall we say. But what it means is if you can pry the child off of this, these are so much fun that it's hard for them to let go. But if you can pry them off of that, they can transition very easily to a 2-wheeler without training wheels. So we can see this very basic thing, wheels, a handlebar, and a seat. So what does that all have to do with energy and water? Well, in an industrialized society, we like to push the technology envelope. We like to make things better, faster, and cheaper. But does that make sense if you don't have access to electricity? Or does it make sense if you don't have access to water? Or it takes you a while to get it? Let me define this term, appropriate technology. We've actually heard a number of really great examples of appropriate technology in the last talk. The stove. The stove is a fantastic one. Thank you very much. Appropriate technology, and when it's used in the context of the developing world, and oftentimes it is, what it means is it's technology that uses low-cost, locally accessible materials and solves a problem that actually exists in the town, not one that we think exists in the town. Okay? Oh, why did I define it? I defined it because I wanted to talk to you about using existing water resources to generate electricity in places where there is limited access. This is something I've been thinking about, again, for the past couple of years. And it's led me to develop some very interesting professional relationships in Pakistan. And here what you see is a northern landscape. Pakistan, by some statistics, has, or 50% of the population of Pakistan does not have access to electricity. We know that rural electrification has a number of benefits, right? You can name these off: economic, educational, health. you don't have to think very hard about the fact that you can make more product if you can use machinery, or you can read more if you can read into the night, or if your food doesn't spoil if you have access to refrigeration. You know all that. So what you see here is a beautiful landscape. What you don't see here is the 4-room plein air hospital that only has power for 12 hours a day at best. And I should say, at the risk of sounding overly dramatic, what you don't hear is the crying sick infant inside the hospital. And I will tell you that that made it very clear to me that we really are a world apart from the medical resources that I have access to for my children. So Pakistan is, the northern parts in particular, are very well suited to micro and pico hydro. There are, in fact, hundreds of these dotted across the landscape. They've been put in typically by non-governmental organizations, by aid organizations, or by the government. So what do I have to bring to the table here? What can I bring? I'm an engineering professor, and I live in an industrialized society. What can I bring? Well, this is where I circle back to education. And when I circle back to education, I think about my own education. I have about 25 years of experience now in engineering analysis, and 10 of those as a mechanical engineering professor at a major state institution working with graduate students and undergraduate students. So I bring a willingness to work with students. I bring excitement, enthusiasm, maybe a little bit of experience teaching design, thanks to some design colleagues who gave me a tutorial in the term that I taught it. So this is what I bring. But most of all, what I bring is a willingness to build relationships around education, relationships between me and them, between our institutions, between students, between faculty. That's really what I bring. I was drawn in by curiosity, and I've been drawn back by the relationships that I have formed. And these relationships, again, it's from me to them, but it's more than that. It's people in their government, it's people in our government, it's people in the most unsuspecting of places. And it's been really interesting. So, okay, here, let me just tell you a bit about a project that we're working on. I'm working on this with another faculty member here at Oregon State and a PhD student. And what we're doing is we're developing a computer-based assessment tool to predict the amount of power potential in micro or pico hydro sites in Pakistan. And the way that we're doing that is we're looking at the water availability, working to couple it with a digital elevation model, and together then be able to figure out what that power potential might be. And admittedly, this is a high-tech kind of a thing. We're interested in climate change, though, so we're entering this with this high-tech computer-based tool, but we're interested in how we can make better use of the resources, particularly as we look going forward into what's going to happen here when we have climate change, or I should say, what's going to happen in the face of climate change. Okay, so I've told you about that. We are hoping to build on our existing affiliation with the Center for Energy Systems at Pakistan's National University of Science and Technology. We'd like to get into doing some more appropriate technology topics. And here's a couple things I just mentioned off here. We have a test loop, a turbine test loop. Here's the turbine in the laboratory, and it can be used for research and education. This is a pretty standard Pelton wheel. So that's something that both the university and the Pakistani Council for Renewable Energy Technology staff are interested. They would be interested in having access to something like that there. We've talked about together, we meaning me and them, we've talked about putting in a site that can double as a field site for experimentation for students and education and to provide power for the village. We've also talked about engaging some of their students in data collection. That's kind of an intriguing idea. But just like John here, I understand the value and the importance of not working on my own and then taking it there, but rather working truly collaboratively. And so that's what we're doing. But I start thinking about what are some other possibilities? What are some other possibilities in the room here? Is there somebody here, either at OSU or that isn't so far from you at OSU, that's worked on what kind of factors impact the adaptation, or adoption, I should say, of technology in such rural environments? What about, are there any of my colleagues here, or colleagues that you know, that have studied how to really put together a successful international research and education collaboration when you're dealing with countries like these two? I would love to know. Now, I'm not saying that micro or pico hydro is a solution to everything. It's been around for a while. It's relatively mature. We're looking at what we can do to make it better, what we can do to make it more accessible. but it's just where I've chosen to start. There are lots of examples of universities and organizations working in engineering for global development. One of the most famous hotbeds of activity is MIT's D-Lab. This is a laboratory at MIT that works on appropriate technology and that really works on design and development. It's very well known. They also have educational offerings, quite a gamut of educational offerings, very, very popular. And they include engineering, but not just engineering. It also, they go into some of the cultural and social as well. So here's another one, Penn State. Rick Schumann at Penn State has a program that he's worked on, put together, Engineering Leadership Development minor with a global emphasis. Rick is he's a very enthusiastic guy, I should say, and this is a nationally recognized program in engineering leadership, particularly if you're interested in international work. Rick takes a number of students to Morocco every year, and he also engages them on other projects. And if you want to know more about either of these things, both of these people, coincidentally, have TED Talks that you can look up. And then we look at professional organizations. I was recently talking to a staff person at our American Society of Mechanical Engineers, and she was explaining to me how their effort called Engineering for Change has come about. Engineering for Change, E4C as it's known, is a group effort between professional societies to try to help connect people. She said she talks to a lot of people who work in this, but don't know about anybody else. So you can just Google E4C and you can come up with their website and you can look at a library of solutions. You can, it's a way, as I said, to make connections. What do we have here at OSU? Lots of them, lots of things. Okay, so here's the gamut. So you probably know some visitors, international visitors. Maybe you know people who do individual collaborations. Maybe you know someone who went on study abroad. You can do study abroads to the developing world. It doesn't just have to be to London. We have an international degree program that I don't think is really well known, certainly not in engineering, and that allows you to get a second degree alongside your first. I can tell you more about that afterwards if you're interested. We have an Engineers Without Borders project, I should say group, chapter, that's working on water projects in El Salvador and Kenya. And then this is really interesting, this IE3 Global Internships. The IE3 Global Internships, they're internships that you as an OSU student can do and get credit for at OSU while you're doing your internship. There's lots of different things that you can do internships in, and if you look at development, there are places like the Center for Disability and Development in Ethiopia, or you can go work on water issues in Cambodia or Guatemala. So here are a lot of resources. I've focused mostly on the ones for engineering, but I know, there's lots more if we go outside of it. Something like the social entrepreneurship class in business. But all of these things, that's a start. So what else? What else can we do? We have things, and what do we not have? And what do we have? What can I do? What can I bring? So I've told you about my interest in Pakistan. This is a picture of Vietnam. Vietnam is one of a number of other Southeast Asian countries that have a very appropriately suited needs and resource profile that makes it suitable for micro and pico hydro. By some estimates, there are thousands of these little hydro sites all over Vietnam. And they're so small, in fact, that they call them family hydro. So it's interesting. Can we reach out to them? Coming back to OSU. So one of the tips in preparing a TED Talk is to think big. Thinking big. If I think big, can I think about making us into a national or internationally recognized leader in the study of micro or pico hydro? Okay. What about, but that's pretty limited. So what about sustainable energy for the developing world? Could I do that? Maybe. But if you know me, then you know that making a statement that is so bold is very much outside of my comfort zone. And if I think a little bit bigger, I ask this question of OSU. I ask the question of, could we, OSU, develop a program in humanitarian engineering that really does stand out? And if it can't be a degree, well, maybe a global development minor, maybe a certificate program. What are some of the options here? Maybe it's just a matter of connecting interested groups inside and outside of engineering. I'm going from the really big to the less big, but still doable. Maybe it's just better advertising what we have. Think about these IE3 global internships. Maybe you didn't know about them. It's when we do these types of things that we really grow students who can go out and make a difference. These aren't the only ways that you can make a difference, but they are. This is one way that we can grow students, that we can teach students and educate students in a way that allows them to go out into the world and make a difference. So one of the side effects of this is interesting, is that when I put on my webpage an interest in sustainable energy in developing world, I noticed an immediate uptick in interest. So what I find is that there are more, that this is an area that's very interesting to students, particularly a more diverse pool of students. We've been talking for years, decades really, about how to engage more women and underrepresented minorities in engineering. I'll talk about women here because I have those statistics. You can argue that, oh, maybe we need it because we need to access the whole population to get the best people for the best technically trained workforce, or maybe we are better at generating a solution to a challenging problem when we include a more diverse set of perspectives. Nonetheless, the percentage of women getting a BS in engineering in this country has gone down in the last 10 years, 2%, to 18. Mechanical engineering, 11. This is consistent with what I see in my classes. I taught a grad class last fall. In this graduate class, I had, 12 or 15 students. And what's so remarkable is what was unremarkable. I did not have a single female in that classroom, and I didn't even notice it until I was 5 weeks in. And somebody asked me, and I looked at my roster. I looked at the students, and I noticed it. Women sometimes report that they don't feel that they fit, despite similar performance. They don't see a human face of engineering. The National Academies have been spearheading an effort to change the conversation, to combat public, you might say, misunderstanding of what engineering really is, to better convey that it is, in fact, a creative problem-solving endeavor. Your daughter comes to you and says, I want to go to school and I want to do something really creative. Do you say, yeah, you should do electrical engineering? Probably not, but maybe you should, right? Maybe you should. So they've engaged marketing professionals, and by engaging these marketing professionals, they've been looking for, they've tested, field tested, what kinds of taglines better convey the true nature of engineering. And I'll just name two here. One is, engineers help shape the future. That's powerful. We're shaping the future. Engineers make a world of difference. That one's really powerful. I mentioned earlier that when I put this little, sustainable energy developing countries, I was relatively new here and I didn't have, well, still don't actually have a good web page up. I noticed an uptick in interest from applicants, particularly women applicants. And you could say, okay, well, is it coincidental? I don't think so. And I'll tell you, I don't think so because of the conversations, the individual conversations that I have with those students. When they tell me what they're interested in and they tell me their passions, I don't think that it's coincidental. Amy Smith, so she's from the D Lab, when she talks about the composition of one of her classes in an interview a couple years ago, she said that in this class, they had more, she rarely has more men than women, and at one point she had a ratio of 10 to 1, that's 10 women to 1 male. So let me ask you this. In summary, we talk about creativity and innovation in engineering. There's a place for it, high tech, low tech, the industrialized or the developing world. And what I'm asking you tonight to think about is to ask yourself, what can you, in your role as administrator, faculty, staff, student, alumni, or community member, do to help us make a world of difference? And if you're thinking about engaging university community in global development, then maybe we should talk. Thank you.